Welcome, ladies and gents. My name is Luke Allworm, and I'm here to discuss some of my ideas and hypotheses for Neil deGrasse Tyson's Astrophysics for People in a Hurry. It's a really great book. I actually read another book that he had done before that I think is a little bit more comprehensive, but this one's kind of a condensed version, and it's super easy to read and very enlightening as far as the nature of our universe. So I do want to say that he actually had a amazing way of putting off information to the layman and really getting you engaged in the material. And Neil also is kind of like I don't know, relaxed, and I like his way of going about the world of science. So hopefully this is entertaining for him as well, even if everything I say in this video is completely false. I don't know. They're literally just observations and basically pondering some of the things that he had said in the book, where he said we either didn't have information, we didn't know, or we hope to eventually someday find the information for certain topics. Well, one that struck my mind was throughout his book, and I have a whole little slide that I'm going to read from so that I can kind of get you in space of where my line of thinking is. He wrote this book, and I basically went through and I highlighted notes and stuff, questions that I wanted to have answered, and I ended up creating a new hypothesis for the model of the universe. So whether this is actually true or not, who knows? Most likely I'll either be debunked or whatnot. I looked on the internet trying to find answers for stuff, and I could not find what I was looking for, so maybe somebody can lead me in the right direction for this. Let's first start talking about the scientific method, which is literally the most amazing structure of finding about data and quantifying data and trying to understand the nature of reality. So using that just by observation, I don't have a mathematics degree and I don't have a science degree, but I know a little bit about a little bit and a lot about a lot, or whatever. You know. So what we have here is in mathematics, you usually have a set of information, and then you have subsets that go inside the information. So in this sense, I'm actually going to go right into my first hypothesis, which is the Big Bang. So the current model is basically that we have one universe that was created by one Big Bang, and then scientists eventually went into having multiverse, alternate dimensions, stuff like that. I'm not really sure the science behind all that. As I said, I'm not a scientist, but I have no interest to try to contest a scientific theory, because in science, a theory is literally the pinnacle of knowledge. So rather than contesting something that's already existing, I'd like to just play with what we got and see if maybe some more tweaks need to be made to our current model. So that's what I'm going to do. So in mathematics, we have the universe. We have one universe in my hypothesis. And in that universe, we have the subsets of multiple Big Bang that occur. The reason why I say this is because I feel that a Big Bang is not a singular event. I think it's a reoccurring event. I think the universe is so massive with the amazing natural phenomenon that happen in it already. I just, for some reason, can't think of a Big Bang as being a singular event. I think that maybe it happens in multiple events and throughout the universe, and I think we're going to tie it in using some information about black holes. So for example, on my model, if we did have more than one Big Bang event, like we have this one, I put like, you know, a little symbol for the Milky Way. So this is literally like, this is our Big Bang event. Let's say millions and millions of eons prior to our actual scatter, there was another Big Bang event that is slowly, it's been expanding for such a long time, it's already pretty much dead. So most of the matter that has been created, or energy and matter, that have been created within that universe is probably dying out, in a sense becoming extinct. So we have a whole acceleration of matter that's going into our radius of our Big Bang event, which means that one of the things that he had mentioned in the book was that, you know, they were unsure about the acceleration of the matter that was exploded from our Big Bang event. So he said some of the places were accelerating fast and others were accelerating a little slow, which if you have resistance, I would think that that might be an answer for why matter would go slower, because we're literally expanding matter from our Big Bang event into a previously known Big Bang event that's going the opposite direction. So you're going to have friction. So I feel like that might be one observable instance to try to prove that maybe there was multiple Big Bang events. I also made a couple other ones just to illustrate the expanse of the universe as far as the Big Bang event. I had one that didn't literally reach into our Milky Way yet, so that we have matter that's out there that we haven't even discovered yet, that's not interacting with our Big Bang event at all, but we do have some interaction between these two sets of Big Bang events, which maybe we can have some measurable data to try to prove if this model is accurate or not. And I say that as foreshadowing because I feel like a black hole we know nothing about, but we're slowly getting more information as far as properties of its nature or the energy, or even as Hawking has brought up, the radiation that might be exhumed from it, which I'll get back to that in a little bit, because I feel like that might be an observable instance where I can try to connect some more dots. But basically we have a Big Bang, and you have this newest Big Bang that's happened, which maybe we haven't been able to observe one yet because these are expansive amounts of time. But out of a curiosity, I wonder if the data that we collected on gamma rays, for example, or supernovas, for example, I wonder if these are actually remnants of a new Big Bang. I could be wrong, who knows, but just putting the idea out there. But let's just say you have all these tremendous forces that are being spewed out when a Big Bang event happens. I almost feel like what else in the universe is strong enough or has such power that it can actually condense molecules and elements into such a tight space for them to explode somewhere else. And I feel like a black hole serves that purpose. So in a sense, a black hole would be like an enzyme that's inside your cells. I think it collects matter throughout its lifespan. I think it condenses all that matter into, you know, as they postulate, you know, spaghetti noodles or whatever. But I feel like maybe there is something at the end of that black hole on some other, you know, exit to another part of the universe, and all that matter that gets condensed in that little tight space ends up exploding into a new Big Bang event. So using Stephen Hawking's information, I would also say that he kind of corroborates a little bit too from what he was working on, that there is a difference between matter and antimatter, and perhaps my model would be correct with concerning the black hole, because he did some work on the black hole as well, recently, just saying that it actually gives off a radiation, which is eventually the black hole will dissipate. So I also hypothesize if it does dissipate, this conceivably would be an observable fact to why black holes actually have a lifespan and have a more of an integral purpose in the universe. And in my case would be that its function is literally to birth new Big Bang events.